Welcome! We're about to dive into the amazing story of how we figured out what an atom actually looks like. And trust me, it's a wild ride, full of shocking twists and absolutely brilliant ideas.
So, let's kick things off with a huge question, one that people have been puzzling over for centuries. Imagine you take something, anything, and just keep cutting it in half, then in half again, and again. Where does it stop? Like, what's the smallest possible piece you can get?
Well, the ancient Greeks had a pretty cool idea about this. They figured eventually you've got to hit a point where you get a tiny particle that you just can't cut anymore, right? They called this atomos, which literally means uncuttable. And this was the atom, the fundamental building block of, well, everything. But here's the thing, for literally thousands of years, this was just a cool thought, an idea. Nobody had a clue what an atom might look like or if it was even real. That is until we get to the 20th century, when the first real scientific model was put on the table. All right, so let's get into it. The year is 1904. A scientist named J.J. Thomson had just discovered the electron, and he proposed that the atom was basically a solid ball of positive energy, kind of like a blob of positive goo. And sprinkled inside this ball were these tiny negative electrons he'd found.
And to make it super easy to picture, just think of a ladoo. Yeah, a ladoo. The whole sweet part is the positive charge, and the nuts or raisins stuck inside, those are the negative electrons. This was called the plum pudding model, and it was a huge first step, the first real attempt to actually draw a picture of the atom.
But then, an experiment came along that didn't just change this picture, it completely blew it up. This was Ernest Rutherford's work, and believe me, it was a total game changer. So here is what Rutherford's team did. They took these tiny positive things called alpha particles, think of them as microscopic bullets, and fired them at a super thin sheet of gold foil. Now, according to the latter model, these bullets should have just zipped right through, but that's not what happened. I mean, most did go through, but some got knocked sideways, and a few bounced straight back. Rutherford himself said it was like firing a cannonball at a piece of tissue paper and having it bounce back and hit you. Just imagine that.
So what did this crazy result mean? Well, it meant the Lotto model had to be wrong. Totally wrong. For something to bounce back, it must have hit something really small, really dense, and really positive. And because most of the bullets went straight through, it meant the rest of the atom had to be, mostly, empty space. Wow.